to today's GeoTalks Express from Blue Marble Geographics. My name is Sam Knight. I'm the Director of Product Management here at Blue Marble.
And I'm Scott Weber. I'm a Quality Assurance Analyst.
And we're going to be talking about some of the latest and greatest features showing up in Geographic Calculator 2023. Before we get started with the webinar, we'll just take care of a little bit of housekeeping. The format of the webinar today is like it usually is with our sessions. You will all be in listen-only mode, and there is a questions panel that you'll often find on the right-hand side of your screen. We'll be trying to take questions live as we go, so feel free to enter any questions you've got in there. And we've got plenty of time to get to any of those extra questions you might have. Any questions that we don't happen to get to in the session, we'll be following up with afterwards. The session is being recorded. It usually takes us just a day or two to get those posted, and they will be put up on YouTube following this. Some upcoming other GeoTalks Express sessions. On December 8th, we'll be taking on answering your global mapper FAQs. That will be hosted, I believe, by David McKittrick, and it's always a good session for us. For more information on that, you can visit the website and see the additional upcoming scheduled items. We regularly talk about GeoTalks Express. GeoTalks Express came out as a shorter version of our regular GeoTalks conference. So coming up in January, this is our annual conference. It takes place completely online. It's usually a good chunk of the day, a very full agenda this year. We have a number of speakers on a variety of different topics. You can find more information about that on our website as well. There's a little bit of something in there for everybody this year, so it should be a really good session. So please join us for that as well. Also, as we come up to the end of the year, we are tightening in on the deadline for our Blue Marble Academic Scholarship. This scholarship program is open to any undergraduate or graduate level student. The participants have a variety of things they can turn in. It can be everything from your written thesis, a simple report, or a poster presentation. The prize for this is a $1,000 scholarship and a copy of Global Mapper Pro. And the deadline for this is coming up. It is December 31st, 2022. So be sure to get your materials in if you are a student for that. As well, that is also more information available on our website, all the fine details there. So today, Scott and I are going to be talking about what's new in Geographic Calculator 2023. We have a variety of new things that are sort of on the technical level, and also some things that are quality of life improvements for everyone using the application. First, we're going to be taking a look at the addition of what we call base lat-long coordinate outputs with our projected systems. Then we're going to be taking a look at the new GeoCalc dialogs, and we'll get into exactly what a GeoCalc dialog is. You'll hear us refer to those frequently as we're talking about the Geographic Calculator. We're going to be looking at NADCON 5. This is the new National Transformation software provided by the United States National Geodetic Survey for the official transformation method between any of the official survey standards. So everything from the old NAD 27 and US standard datum all the way up through NAD 83 2011 and the various ITRFs and so on. Along with that, there are some extra pieces that are going to give us much more fine-tuned uncertainty reporting. That is an estimate of the accuracy of the transformations that you're doing for your coordinate data. So pretty interesting tool we'll be taking a look at there. We're also going to be taking a look at the output velocities. So for years, we have supported time-based transformations, and folks have requested an output option for the specific velocities being used on a transformation. So we'll be taking a look at how we can get access to that information as well. We've had a popular request on the area calculation job for a few years, and that is the addition of rhumb lines as a type of perimeter for the polygons. We'll be taking a look at that new feature as well. and support for LAS and LAZ setting the specific output version. So this is a new preference that we'll be taking a look at that allows you to finally control the file version of an LAS file or an LAZ file as we write those for output. We'll maybe take a look at a couple other things if we've got some time. We'll see how we're doing towards the end of the session. Okay, so here we are in Geographic Calculator version 2023. And we're starting off as our usual view here in the start page on the job guide. If you're a new user of the Geographic Calculator, the job guide here will give you a quick idea of all of the various functions that you'll find throughout the application. What we're going to be looking at is a few example jobs, and you may be wondering as well, if you're a newer user, what all these jobs down the left-hand side of my screen are in the project manager. The project manager is really just your jumping off point. And so what Scott and I have available here is a workspace that we set up mainly for demonstration purposes. So we have templates of many different types of jobs. You as the user would interact with the project manager just like you would in really any project management mode. So these are individual tasks. What you see in the special features section in the lower part there are all things that I've set up, particular combinations of the normal job types. So interactive jobs, point databases, and so on, just all with our special settings. In this case, we're going to use these to demonstrate some of these different features that we're talking about. So the first thing we're going to talk about is base latitude and longitude coordinate outputs. And these are found in a couple of different places. We'll first take a look at them on the interactive job. Now, when I click over to the interactive job, we're going to see that I have some new fields here that are already lit up. I've already got some datum transformations set. I've already got my coordinate systems in place. And I already have these new fields over here for base latitude and base longitude. This is something you're going to need to turn on if you want to use this feature. So what we're talking about here in the base lat long is I have a coordinate on the left-hand side. So this is my input coordinate, and we're saying that is a NAD27 based coordinate. Over here on the right-hand side, we're both doing a projection to that coordinate, and we're also doing a datum transformation in the middle. So we're doing a series of NADCON5 transformations to get that NAD27 up through the various epochs of NAD83 to our current modern survey epoch. What we're going to typically get when we have a coordinate system, such as a projection specified, is we would have our lat long in, and you would see northing and easting for output. Now, this was actually came to us from a user request from a few users over the years, is that when they're dealing with projected coordinates, they actually also want to see what we call a base latitude and longitude. So every projected point has an equivalent point in a lat long. And that's something that I know Scott and I use all the time for comparing whether something is accurately transformed if we're looking at a control sheet. Most control sheets will actually have data given in lat long as well as this extra stuff on the side for your projections if you're going those extra steps. Now, we need to turn on an extra setting to do this. And where are we going to do that extra setting, Scott?
That's under Options, Preferences. And then in that General tab, you should see about 2/3 of the way down, show geodetic base coordinates.
Okay, so we've already got that turned on for our installation. And that's why we have the base lat long showing on our output side. If we had that toggled off, you'd see the same old familiar view of the interactive job that we've had for a very long time. So simply toggle that on and you'll have this new base lat long, and that will only show up when you're using a coordinate system that isn't already a lat long coordinate system. So when we go and actually fire off our calculation here, you'll see what we get is the input lat long on its side. And then on the output side, we get our northing and easting that we would normally expect here for a projected coordinate. And then we also get the base latitude and longitude. So this is the equivalent location on our output datum, so has the datum transformation performed to it, the equivalent location to the projected point in there as well. So that allows a very quick verification of datum transformation if this is something that came to us from, say, a fairly typical survey control sheet for a datum transformed point.
Sam, let me just stop you there. I did notice during the beta test period that the question came in, what is a base latitude and longitude versus, well, what is it? And the answer is, it's just a geodetic latitude and longitude. But in this context, we're just considering it the base geodetic of the projected. And I guess that wasn't, so if we had more space there, we could write base geodetic latitude, base geodetic longitude, but we didn't want to take up that much space. And in the past, you would see these latitudes and these bases if you did a printed report of this job, but now you can see them just interactively right in the UI. So it's a time savings to be able to just see them instead of having to do a secondary job in the geodetic and then have another job in the projected and then write them down from two different jobs. They're all in one handy place now.
Okay. So that should be something nice and handy for a lot of folks to take advantage of, particularly if you're working with control sheets. One side note on that is if you are going from a projected system to a projected system, you'll actually see the base latitude and longitude on both sides of that transformation.
That's true in the interactive job. And when we get to the point database conversion job, we will see there that it's only available on the output side.
Right, the point database job is a slightly different animal in that regard. Okay, so also while we're on this form, we can also see some other new fields at the bottom there. So beneath our scale and convergence values, you'll see a north-south and east-west uncertainty. The uncertainty is actually a unique value to the NADCON5 transformation type. So this is the uncertainty sort of reflects the wiggle room that is in the transformation, in this case, the combination of transformations that we have, stepping us up through all the various epochs of NAD27 to the modern day NAD83 2011. Within these tables, so NADCON5 is a grid table based transformation. Within these tables, for the whole area that is covered by NADCON5, so that is basically all of the continental US and the outlying US territories, within those tables, there are additional tables of the uncertainty of those transformations. Now, a lot of folks get a little uncomfortable talking about uncertainty and accuracy of datum transformations because we all like to believe that our points are highly accurate and they're survey grade points, and we start we start making people nervous when we say there is an uncertainty or an error or some wiggle room in there. But this is really endemic to the process of datum transformation. Datum transformation is a process of changing your data, and the transformations that we use every day are the result of empirical data collection. So there is some very small statistical uncertainty in the locations that the points come out. On a normal datum transformation, when you're selecting those, you'll simply see an accuracy listed, and that is an overall accuracy estimate that covers the entire area of that datum transformation. And those vary widely from a few centimeters to 10 to 15 meters, depending on the particular transformation you are working with. The uncertainties for these are basically cumulative errors. So in this case, in NADCON5, each of these that we're performing 5 different transformations for the combination we have on screen here, and you'll see those in the coordinate transformation box in the center. The process for calculating the uncertainty is each step of that has its own individual uncertainty, And the method spec'd by the NGS for these is to accumulate them. So basically each of the levels of uncertainty is summed, and the sum is the value that we have out here. So in this case, our north-south uncertainty, the sum of all 5 of those uncertainties in the center totals up to 0.31 meters or 31 centimeters. Likewise, the east-west uncertainty totals up to 0.28 meters or 28 centimeters. So those are accumulated, and you'll actually see those. You can verify those as well by using the interactive page on the what's called the NCAT tool, the National Coordinate Transformation Tool, online, provided by the NGS. That's actually how we validate our own points. So that's something Scott in particular has spent a lot of time working with. While we're in the neighborhood, I see there's another question came in while we're talking about it. What are the units of the convergence in here? So you'll see scale and you'll see convergence. The scale value is it's a scalar value that refers to a unit called unity, and it's basically 1. So it's a coefficient of 1 is perfect, while convergence is an angular value. And those, I believe, are given in arc seconds.
I believe the convergence is in degrees by default.
Is that a degree by default?
Yes.
Okay. Sorry, my bad.
It's set in the preferences. It is whatever the angular setting is, and I believe that is degrees because that's a generic angle across various usages throughout the jobs.
Okay, so now we've covered all the new fields that we have on there. Let's move along a little bit, and we can take a look at the new GeoCalc dialogs. And so this is a particularly large chunk of work that has gone into the new calculator. So I'm going to climb in here under the data source menu, and we'll go down to coordinate system definitions. And this is a dialog that's been with us for years and years, and it's really the first time in probably about 15 years that we've done a major overhaul of the look and feel and the behavior of this dialog. Now, on first glance, we see there's a lot of coordinate systems specified in here. We still have all the same contents of the database that we used to. We have a search to get through it. We have some various folder categories. But the layout and the look and feel is a little bit different than it used to be. So these dialogs have been completely rewritten from the ground up. And we refer to these as the GeoCalc dialogs. And that is because GeoCalc is really the engine behind the Geographic Calculator. So Calculator is the application that we interact with, does all of our things like file handling and so on, has all the specific user preferences and stuff. But under the hood is a tool that we actually sell separately called the GeoCalc SDK. And you'll find this embedded in many other geospatial packages, particularly around the seismic industry and in a number of geospatial tools used for things like LiDAR processing and so on. So you may encounter these dialogs in other tools and say, that looks very familiar. And that's because it comes from our same toolkit that you'll be using right here in the Geographic Calculator. So that's undergone a complete overhaul on how you as the user interact with all of the database of parameters of anything. So in this case, we're looking at our database of coordinate systems, the dialogs that you interact with similarly for datums or units or coordinate transformations. Those have all undergone this same look and feel update. Now there are some major chunks of change that have taken place in here, and there are some more subtle things as well. So we're going to take a quick look at the overall behavior of this. First of all, you'll notice that the search field has gone to the upper left-hand corner. The search used to be right across the bottom, and you would enter some terms in the search. You would hit the go button, and it would perform your search, and then you'd get a fixed list that was your search results. What we've tried to adopt in here is a little bit more like a live filter or an online shopping type of filtration based search. So the search parameters are now live. So if I am looking at the database of all of the coordinate systems and I start typing, you'll see that list filters down as I go. And the more I type, the narrower my search becomes. I'm searching within the entire contents of the database. So I've typed WGS8 and you'll see it very quickly filters me down to all of the coordinate systems. So now this is across geocentric, geodetic, projected, every single category in there. I'm searching all of those in one view. Now, where things get a little bit different is in the different modes of performing this search. You'll see there are some advanced search tools available right below the search field, and there's a new checkbox actually over on the right-hand side to include subfolders in the view that we have here on the right. So by default, I'm going to be looking at the top level of all of the coordinate systems that we have in there. If I narrow this down and go down into each of the categories, you'll see that same search has been applied, but I'm now searching within one single subfolder. So I have some geocentric WGS84s and I have some geodetic WGS84s. If we go down under projected, we'll find some in there as well. The farther I go down into these given categories, so let's just grab on to geodetic, and I'm going to expand this list just to show what the subfolders checkbox does for us here. If I toggle off the include subfolders, you'll see all of my results actually disappear. There's nothing shown in the screen. By toggling off the include subfolders setting, that actually puts us back into the older mode of navigating the data source. So by unchecking the subfolders option, that makes it behave exactly like it did in Geographic Calculator 2022 Service Pack 2 and any previous release going back about 15 years. In that mode, we were only looking within whatever the particular folder was that we had selected. If you had any other folder selected, it would not show you anything else. So you had to be much more fine-tuned about where you were looking if you wanted to see an entire group of systems that were likely to be in the same place. By toggling on the include subfolders option and using the live filtered search, it allows us to search much more rapidly across the entire database. And then we can still always get back into the folders where we're looking for these things. If we want to know where something is found, we can again just right click on that and say open containing folder, just like we always could, and it will take us back to the highlighted state of where we actually find those particular parameters. So the include subfolders setting is particularly handy if you're trying to get used to the new version and the search is taking you a minute to get used to. Toggle off that include subfolders setting, and then you can browse through the contents of the database one folder at a time, only looking at that one folder, and that'll put you into maybe a more familiar view. To try that out, you can use the include subfolders option, and what that does is it shows you everything within the particular folder and then all of the subfolders. So it's very, very useful, particularly if you're looking for things that cover more than just one localized region, or in some cases there are coordinate systems that you might be looking for that are conventionally assigned to one location but actually get used a little bit more broadly than that. So with the toggle there and the new live search tool, it's a very, very much more speedy way to get through what you're looking for when you're pretty sure of what you're looking for. Now, we also have some tools in here that are much more useful when you're not entirely sure what you're looking for. And that is found under the advanced search and the search types. So the default search type is simply all, and that will search through things like the names, the remarks, EPSG codes, for example, or any other type of issuer code. But you can also narrow those down into each of the subcategories. For instance, if you're just looking by a particular issuer code, you can filter down based on that, and that'll take you right to what you need. The advanced search, before I do that, I'm going to actually click back all the way up to the top level here. The advanced search opens up a whole collection of new options that are very useful if you don't exactly know what you're searching for. The thing I use the advanced search for mostly is when I'm looking for a projection that I only have some incomplete information for, and I'm say trying to research a particular projected coordinate system for a part of the world I'm not exactly familiar with. This is a problem particularly for international geodesy workers. Let's just describe them that way. Folks working in various parts of the world that they may not be familiar with only partial data. What we're calling these is a multi-parameter search. And so we can do things like filter it down based on, say, a geographic area. And we can do that with a map-based control. So all we have to do is, say, drop a point on the map, or we can very quickly draw a box on the control and filter down that way. We've had a similar control to that in the past. This allows you to create your box as a secondary step rather than as a primary limiter. And it's useful in a little bit of a different way than our other box tool, which also actually does still exist. One of the things I typically do a lot is I may know the datum that I'm looking for a coordinate system with, and I may know the projection and maybe some pieces of the projection if we're trying to research something that is older, maybe has only partial metadata available to it. So one of the things I might very commonly do is search for a coordinate system that has a WGS84 datum, or maybe it's a NAD83 datum. Coordinate system if I'm looking for something custom, and I could also search by the geodetic if I knew a specific geodetic for it. What I'm going to do is just go by the datum, and I'm going to say let's look for a projection, and let's say I'm looking for a transverse Mercator projection, and if I only know where the coordinate system is centered. Let's say I know that the map I'm working with has a center at -69, which is near our part of the world here. And if you had some other parameters, you could fill those in as well. But I can generate my list based just on the horizontal datum that's at use. I could pick linear units or angular units if I was looking for a geodetic system and so on. But you fill out as many of the pieces as you have and fire off your search. And what you'll be returned with is a list of all of the coordinate systems that center on that particular parameter, however many you've given it. And in my case, we see I have a selection of different variations of UTM zone 19 as a common coordinate system centered on that area. Searching in other international places, one of the very common examples I've used this is in researching coordinate systems, particularly in China. There is a series, or shall we say several series of coordinate systems that all have co-located central meridians. They're evenly spaced, they're all transverse Mercator, but they're used in different subfolders. They have different geodetics on them. This type of multi-parameter search allows you to very quickly get down to the end of what you're searching for. Let's see. Why did NAD27 show in the result? Question coming in here. NAD27 in this case is showing because of the search parameter. So that was pretty astute there. I searched on NAD83, and you'll see the top two entries there are NAD27. The reason for that is that NAD20, those entities actually mention NAD83 in the remarks for those coordinate systems. So the type of search we're executing sometimes will carry some extra things in there, but I know off the top of my head that those particular systems mention NAD83 as being a later replacement for it in the remarks of those. So that's why those.
So if you change the search type from all to name, would those then filter out?
Yeah, if I was doing a name search, those would filter out of there. So that is sort of some of the major new pieces of the basic part of the dialog themselves. You'll notice as we are building up these multiple parameters, we can do searches within searches, and so various pieces of this light up across the top of the dialog. So particularly transverse Mercator is the projection, and minus 69 is the longitude of origin of those systems, and then over here NAD83 is the datum. We can remove any piece of this simply by clicking on the little trash can icon. And this is how we're referring to the typical online shopping type filter. When you're looking through a database that contains thousands and thousands of things, sometimes you want to tweak just one piece of that to eliminate it from the search or add in another. We can click each of those independently to get rid of them if we want to. Likewise, we can also just simply click remove all filters, and that will wipe us out and set us back to the master view. Now let's take a look at a little finer piece of the behavior here in our new dialogues, and that is how we actually interact with one particular system at a time. So let's just go ahead and grab onto a good old familiar system here for us, NAD83, and we'll use this as an example of the other piece of the new dialogues in here. Now the screen we've just opened is our typical details pane. So this is where we actually store the parameters of each of the what we call geodetic objects in the database. So in this case, we're looking at a geodetic coordinate system that is a lat-long coordinate system of NAD83. That has different chunks of its own definition. So we take a look under the identifiers and we'll see its name, any noted remarks that typically come from the EPSG database, and a whole series of identifiers. So again, these are all searchable in those new dialogues depending on what type of search you're executing. The details, however, is a drill down list. So this definition is made up of other definitions. So namely, in the case of a geodetic coordinate system, it's made of a horizontal datum. So the horizontal datum behind the NAD83 coordinate system is NAD83. If I click the info button behind that, you'll see it opens up a new panel. Now, in previous generations of these dialogues, we would open up a series of cascading windows. So that would be, we'd have the horizontal datum would open a new window on top of the previous window. And likewise, if I then clicked into the ellipsoid, that would open another new window. So we could end up filling up a screen pretty fast with a whole bunch of stacked windows on top of each other. The more and more parameters we get in here and the deeper we get into some research, that becomes less and less useful to have all of these windows. You have to close all of them going back all the way through. So this now has been replaced by a single window, and you'll notice that it is actually pinned to the screen. If we resize the window behind there, the new window is actually pinned right to the middle of this screen. There are also some new buttons in the upper left-hand corner. So there's a double triangle and a single triangle. So the single triangle is essentially like a back button. So I'm looking at the ellipsoid right now, and I got here from the horizontal datum. If I click the previous triangle, that's going to take us back to the horizontal datum. If we go back in there again, I'll just pop open the ellipsoid. So here we are back in the ellipsoid. If I hit the double triangle to view the top object info, that's going to take us all the way back to where we started. In this case, the geodetic coordinate system. So a lot speedier way of navigating through a whole series of cascaded parameters. This gets back to that one sort of idea that's been kicking around in the geodetics industry for many, many years now, is that any piece of data has about 80 different parameters behind it regarding its spatial reference. So by the time you stack many of these different parameters on top of each other, when we typically interact with these on something like a projected coordinate system, by the time you get down to the linear units used to define it, we're talking about a lot of individual windows that we could potentially stack on top of each other. So hopefully you'll find this a very useful speed up to basically get through the research portion of the task a little bit more efficiently. So let's go ahead and close back out of there.
Before you do that, Sam, one thing that's changed is in the old dialog, you would see your recent list among the folder view, and now you simply get to that from the search types. And that's something that for me, it took a little getting used to, so I thought it'd just be worth mentioning now.
Yep. And it looks like I have cleaned my installation so many times I don't actually have any recent types in here other than Net 83. Okay. So let's get back out of here and we can take a look at some of the additional new parts of the calculator interface itself. So we started off by taking a look at the base lat long and the NADCON 5 uncertainties. Another piece of this that's getting into the much more fine-tuned portion of the geodetics is around velocity outputs on time-based transformations. So to take a look at this, what we're going to do is flip over to a job where we have set up a time-based transformation, in this case using horizontal time-dependent positioning. This is another one of those very useful toolkits that comes to us from the National Geodetic Survey here in the States. So on the left-hand side, I have WGS84 G1762, one of the more modern iterations of WGS84. And on the right-hand side, I have an older NAD83. So I have NAD83 NSRS 2007. These both came along with particular dates. And if we were looking to reconcile these across their reference frames as well as across different epochs, we would need to use a time-based transformation to do that, such as HTDP. Now, as we go ahead and select these, we've already got our job set up here, so we're going to do the cooking show analogy. As we go ahead and calculate that and get our output on the right-hand side, the velocity information here is not immediately available. What you need to do is right-click within the coordinate point definition box, and you'll see some of those extra options that we have, things like finding an antipode or popping open a particular point in Google Earth display. There's a new option in here for time-dependent velocity, and if we simply select that, you'll get a new pop-up window, and that pop-up window has the velocity for the output point that we have there. So in this case, you'll see these are millimeters a year. We're talking about very, very slow movement. This is the type of movement that we associate with tectonic motion, because that's really what's getting modeled here. Those are the velocities in all three directions, and an important note about the velocity for the geodesists that are paying attention to this, these velocities are surface-based. So all of the transformations, the grid shifts that are used in here are based on surface values. So those are horizontal velocities. So that's why those are labeled east, north, and up. There are some folks may expect to interact with these as geocentric values in other applications. In this application, they are given in those horizontal and vertical directions. So more of a topocentric type view of that information. Now this is one way to get at those velocities, and the other way to get at those velocities is on a point database conversions job. So here we have a similar setup, so two HTTP related systems, and they have epochs filled out for those. So they enable a time-based transformation to be used for in the center. The output velocities here, in order to write those out individually in the spreadsheet, those need to be specified on the job. Now, before these will light up, this is, again, another new preference setting. So in order to get these to light up, just like the base coordinates tab, we'll find these under the options, in the preferences, on the point database settings. And on the point database preferences, you'll find a new entry down here at the bottom of the list to show time-dependent velocities on the PDC job. Without that toggled on, you simply won't see those preferences recorded down there. So I have mine already filled out, and when we go to execute our transformation, again, this is only if you have a time-based transformation set in the middle. When we go to write those out, you'll get all of those same velocities indicated in millimeters per year again. Okay, and I think that's going to do that for the velocities. Let's see, I think we have a couple questions come in. Okay, there's a question. Somebody noticed EBCS as a heading on one of the menus that went by there. EBCS stands for Early Bound Coordinate System. An early bound coordinate system is a coordinate system. It's either a geodetic coordinate system or a projected coordinate system that comes along with a default transformation relating it to another coordinate system. Typically, this is the other coordinate system is typically going to be something like WGS84 that is used for a midpoint in a two-step transformation. Early bound transformations are something that is sort of found in simpler geodetic handling applications. These typically tend to be some of the kind of older applications or applications that take a simpler view on some of the geodetics. Geographic Calculator on the whole is what we refer to as a late bound coordinate system model, whereas that is when you see NAT83 on my screen here and you see WGS84 G1150, those coordinate systems do not already have a coordinate transformation specified for them to get to any other system. We use our coordinate transformation box in the center to interactively pick a good combination for those with whatever combo of datums we happen to be using. So difference between early bound and late bound there. Okay, let's see, next up.
Might just mention that Geographic Calculator's default data source has no early bound coordinate systems by default. They're generally user created or imported from some other source.
Yes, and important note there. Next up, we have a new input on the area calculation job. So a lot of these things we're talking about today, I'm sort of remembering individuals over the years who have asked for some of these features, and a lot of these things on our list today actually come to us straight from end user requests. So this is just a good time to note if you have things that you would like to see in the Geographic Calculator, you know, whether it's just a simple UI change or whether it's a new type of calculation, always please feel free to touch base with us and talk about what that extra output you're looking for is, because everything that we're talking about today came to us from end user requests. So this is a fairly simple request that was actually a little more complicated to implement mathematically. This is the area calculation job. So a lot of folks are familiar with the area calculation job as a place where you can manually define a polygon. So what we have here is lat-long waypoints and northings and eastings in a projection, defining waypoints of a polygon-shaped area. Now, where area calculation gets very fine-tuned is in how we actually get from point to point around the perimeter of our polygon. So in our default mode here, we have all of the connecting lines are defined along geodesic paths. That is a great circle path. We don't always have to do that. If we're in, say, a projected coordinate system, typically we would be following a grid line path. Seafaring navigation for a very long time has used rhumb lines. So there's all different ways we can get between some of these positions. Now, where things particularly get tricky is when we're working in an area. This is a very common application in offshore work where folks are dealing with things like lease areas in offshore areas. So say, for example, we are working right at the edge of a country's national waters. The boundaries of the internal waters within the national space are often going to be in rhumb lines or in grid lines, depending on what projections they're dealing with, while the international boundaries will be specified with geodesic segments. So the problem here is why the area calculation job exists. So each of these segments between every vertex in that polygon can have their own navigational line. For a long time now, we have supported geodesic lines, parallels, and grid lines, some of the very common ways to specify those areas. What we have added in this time is rhumb lines. So this has been a popular request that actually was a little bit on the complicated side for us to do. We had to learn a few things to do this. So what I'm going to do here is just change a few of these connection lines to rhumb lines versus the geodesic, and I'm going to reprocess that job. Now, when we move over to the viewer, you'll see some of these segments have now changed color. So we're getting in between those points along a different path. Now, for those of you who are maybe not so experienced with area calculation, the following of these different paths actually will calculate different areas. Rhumb lines, geodesics, parallels, grids, all of these different navigational lines occupy different lines that go in different places. And what that will actually do is affect the area bounded by that polygon in different ways. Where you see the largest change on here is when we have different vertices connecting via different paths. So if it's all geodesic or if it's all rhumb line, sometimes you'll see fairly close results. As we start mixing the types on some of those internal boundaries, that's where we really see some divergence. In cases of things like oil leases in offshore areas, those numbers of the contained area are used directly for valuation of product in those areas as companies are making deals with particular governments and things like that. So this is a fairly important nuance of this calculation, and we hope a lot of folks who've been asking for this over the years will enjoy using that. All right, next up, I didn't have this on our list at the beginning, but I figured I'd mention it while we're in here, just at least briefly. It's the same type of change that we made on our line intersection job. So our line intersections have always been able to follow geodesic or grid line paths, depending on the coordinate system you used. If you had a geodetic coordinate system, the line intersection type would follow a geodesic path. If you had a projected type, it would follow a grid line path. Now we've added the ability to select rhumb lines on this interface as well. And it basically does exactly the same thing as it does on the area calc job. It just follows that different type of line to follow to where the lines are going to intersect in the middle, regardless of the type of coordinate system that you have specified for your lines. Okay, and last up, we're going to take a look at, this is actually a very simple preference that we've added to the application about LAS and LAS file versioning. So in the general preferences for the application, if we click onto the vector processing tab, you'll see there is a new setting right in the middle there to upgrade the LAS or LAS version. If you have a LAS file, this applies to LAS or LAS. It's actually the same. It's really the same structure within each of those. Just one is compressed and one is not. What we've done for a very long time is if you, say, for example, fed in a LAS file version 1.1 into a vector conversion job, you would get a 1.1 version out. The new setting here allows us to upgrade those to whatever other version you want to use. So typically this is going to be an upgrade function. If you have, say, a LAS 1.1 or a 1.2, maybe you want to upgrade that to a 1.3 or 1.4, depending on the compatibility you need with some other software that you're going to be loading your point clouds into. So now we've had this, the new preference. The default behavior is simply same as source as it's always been, but if you need to fine tune that version, you just hit the drop down and select whichever other version you want to force those to go out to. Okay, and I think we have just about come to the end of our time here. So if anyone has any questions, now would be a good time to put those in. Um, I see one question. I think we talked about this a little bit earlier on about how we total up the uncertainty on the NADCON 5. I know this will be popular for particularly US-based surveyors. Do you want to take that one, Scott, about how we add up the errors for NADCON 5?
Yeah, basically there's an error file for each of the individual transformations, and then at any particular point we have the estimates of the uncertainty interpolated to the particular input coordinate. And for each of the directions, north, south, east, west, and vertical, if it's relevant to the transformation, we're going to total up, just sum those errors. Sorry, uncertainties is the word I should be using. And we've tossed around the idea of what the best way to capture the total uncertainty for a concatenated transformation that in this case has 5 parts. But right now we're following what the NGS tool is doing and their guidance and simply summing them. So in a way that is giving you kind of a maximum uncertainty that you might get. It could be that some of those uncertainties would cancel out, but for now, we're simply summing them. In this example, NAD27 to NAD83 is going to have the largest uncertainties that particular transformation. We're going from the old NAD27 into the NAD83 realizations. And if you were to break these down into individual transformations, you would see that the lion's share of that uncertainty is in the NAD27 to NAD83. You'll also notice that if you turn on the verticals, you will not get a uncertainty for the NAD27 to NAD83. Those appear to, at least for every point that I've experimented with, there do not seem to be vertical uncertainties in the NAD27 to NAD83 transformation, but you will get them among all the different NAD83 realizations. So if you don't see a vertical uncertainty, even when you have verticals turned on, it may be because you're doing something like a NAD27 to NAD83 and it simply doesn't exist and we don't display in that case. We don't want to put a 0 there and have you think that the uncertainty is perfect when it's actually just non-existent.
Yep, this is another one of those cases where 0 means a thing, and so we don't want to put a 0 that shouldn't actually be there. Okay, let's see. Oh, we have a question on how do we, I don't think we talked about this. How do we turn on the uncertainty boxes? We talked about how to turn on a few other things, but not the uncertainties. The uncertainty boxes will simply show up if you select anything involving a NADCON 5 transformation. If you're picking NADCON 5 for your horizontal work in there, the uncertainties will simply light up on the interactive job here. On the point database job, that is where we have something to turn on. And so again, that is under options, preference, point database, and oh, whoops, I'm misspeaking right now. I'm sorry. Live question answer. They will simply appear. I'm going to let Scott take over here because I'm tripping on my tongue right now.
Yeah. So for all of the NADCON 5 uncertainties, they simply turn themselves on when they're applicable. Whereas for time dependent, and the reason that those come on automatically is because we can easily detect that we're using NADCON 5 and they're relevant. Whereas for the time dependent case, there's lots of different time dependent sorts of transformations. The dates have to be turned on. So it's a little trickier. So we put a preference in there so that the user has to do the manually make them appear or not.
Okay, let's see. Is Calculator 2023 available to users who purchased 2022 and maintenance? And so the answer to that is yes. Any user, we sometimes have users that will standardize on a version even for several years. So the shortest answer to that question is if you have any type of calculator maintenance subscription that is still a valid subscription, you are entitled to Geographic Calculator 2023 right now. It will require a license update, and that is the thing for those of you who are maybe on network installations. That is something you'll need to coordinate with your IT folks who maintain your licenses. But those of you who are on single user licenses, you should simply be able to upgrade. But you will need to request a license. So if you're going to install it, you're going to make sure you have, say, internet access, and you properly go through your license request. If you run into any trouble getting updated, you can always contact our tech support team at geohelp@bluemarblegeo.com. And it looks like we've come to the end of our questions. So at this point, I think we'll go ahead and wrap it up. We want to thank everybody for tuning in today. It's always exciting for us to put out a new version of software and get to talk about it. If you have any questions about the status of your subscriptions or anything like that, you can always write into orders@bluemarblegeo.com. If you have any technical issues or if you have any technical questions as you get up and running with Calculator, that would be our tech team at geohelp@bluemarblegeo.com. You can see the web address there on screen, bluemarblegeo.com/geographic calculator, or it's also linked right off of our main page there at just bluemarblegeo.com. Please feel free to join us again soon for our FAQ section on global mapper frequently asked questions. And as well, also don't forget to save that date for our full GeoTalks conference coming up in January as well. So once again, thanks everyone for tuning in. Thank you, Scott, for joining me.
Glad to be here.
And
Thank you, everybody.
We'll see you next time.